I hope y'all enjoy this video. X-Rays by Harrison Hoffman, Jarrett and Peyton.
History. In 1895, German physicist Wilhelm Conrad Röntgen became the first person to observe X-rays.
Description. The X-ray's frequency can vary from 3 times 10 to the 16 Hz to 3 times 10 to the 19 Hz. The X-ray's wavelength range can range from 0.01 to 10 nanometers.
Uses of X-rays. X-rays are used by doctors to see inside of people. Also, X-rays are used for airport security to see inside your luggage. X-rays are used by astronomers to see things in space like stars, black holes, and the sun.
Now here's a little video for y'all to watch.
Light is a form of electromagnetic radiation. At some wavelengths, it appears as visible light. At others, it takes the form of radiation we cannot see, such as ultraviolet, infrared, and X-rays. X-rays have very short wavelengths that, unlike visible light, are able to pass right through most tissues in the human body. Since bones contain calcium, a denser material than most other tissues, they are able to stop some of the X-rays and can thus form a shadow. If you place your hand in front of a flashlight, it will cast a shadow on the wall behind it. In a similar manner, X-rays directed at the body produce shadows on the opposite side that can be registered on film or on a digital sensor, so that bones are clearly visible while soft tissues, such as muscle, are shadowy. As a result, the two-dimensional images formed by the X-rays are quite useful in revealing structures within the body and can easily display fractures in bones.
Interesting facts. X-rays were discovered by accident by Röntgen when he was experimenting with vacuum tubes. X-rays can be divided into hard X-rays and soft X-rays.
Interesting facts continued. The first X-ray was on Röntgen's wife's right hand. An X-ray delivers about 1 million times more energy than a radio wave. That's why X-rays can hurt you. Also, some special X-rays are mammograms, dental X-rays, contrast X-rays, and CT scans.
Here's a works cited page.
History.com, randomfacts.com, the History of X-ray Analysis book, Holt Physics book, and NASA Science X-rays.com. Thanks for watching.
Alrighty guys, this is Peyton Fawn. So we're going to do a couple of practice problems. So dealing with X-rays. So problem number 1. It says light with a frequency of 7.26 times 10 to the 14th lies in a violet region. What is the wavelength of this frequency of light? So first we're going to write out our formula. So it's wavelength equals the speed of light divided by the frequency. And speed of light is always 3.00 times 10 to the 8th. So we're going to take that 3.00 times 10 to the 8th and divide that by our frequency, which is indeed 7.26 times 10 to the 14th. And when you put that in your calculator, you'll get the wavelength of 4.13 times 10 to the negative 7th. Alrighty, for our second problem, it says when an electron beam strikes a block of copper, X-rays of frequency 1.04 times 10 through the 19th are added. What is the wavelength of these X-rays? So once again, we're going to write our wavelength formula, which is wavelength over the speed of light over the frequency. So So we're going to write the speed of light, which is 3.00 times 10 to the 8th over the frequency, which is 1.04 times 10 to the 19th. And when you put that in your calculator, you're going to get an answer of x equals 2.80 times 10 to the negative 11th x, or the wavelength which we're looking for. Thanks for watching.